Welcome to the Fortress webinar, Atom, the compact, robust interlock with RFID coding. Your presenter today is Rob Stark, CMSE, Fortress Product Director, who in recent months has overseen the development of our network and digital product ranges. Rob's going to give an overview of Atom and demonstrate that using RFID actuator coding can provide functional advantages in machine guarding, including hygienic applications. Eve Edwards, our US machinery safety specialist, and I, Malcolm Sharp, will be hosting and join Rob for any questions you may have. Both Eve and I are members of ISO committee working groups involved in machinery safety standards developments. This webinar is about 25 minutes in length. If you have any questions, please ask them using the Q&A at the bottom of your screen and typing your question in the dialog box. We will answer as many as we can at the end of the presentation. If we can't get to your question, we will come back to you by email, so please include your name when you ask the question. This webinar will be available to download shortly, as will the PDF copy of the slides. Finally, we have a very short pop quiz at the end of today's event, and this will be in the form of a poll, followed by a tiebreaker question that you'll be able to answer by using the chat function at the bottom of the screen. Eve or I will explain this process as we get to it. So enough from me, and over to your presenter, Rob.
So thank you very much, Malcolm. I can see it looks like everyone's joined. As Malcolm said, we will try and go through today quite quickly to keep it brief, keep it a sort of bite-sized chunk to take away with. First thing we'll be looking at is around what really drives the whole RFID thing with interlocks, if anyone's familiar with it. And then towards the end, we'll start looking at how it can gain some functional advantages for also hygienic applications in future. So as I said, we wanted to start really with looking at what is this thing around actuator coding and similar. Now, this is a photo I actually took as a snippet from an online website. Unfortunately, it's not a picture I took myself. It is one that's publicly available online. But as you can see here is that someone's put that cheating finger into a safety switch on a machine to try and run it with the door open. You can see in the back left, the door is actually open, and then they're just holding that spare actuator in the switch there. This is a problem that probably many of you have encountered. I remember it from watching machine setters on CNC machines. Particularly if they wanted to take a good look at a workpiece or something similar, they would try and run a machine in an unsafe condition by not having the guards surrounding the machine. This is then something that a lot of research has gone into, and something that really has started to drive safety standards globally. One of the things that really started to drive it was actually a group of Germans that had wrote a study. Unfortunately, it's not available in English as far as I found it, so I did have to do a fair bit of homework to actually read it myself. But the study gives some really nice data about the reasons why people try and defeat safety systems on machines and similar. What's the motivation surrounding it, and what measures can be put in place to try and stop it. This sort of work then went into some ISO standards related to safety of machinery. So ISO 14119 talks quite extensively about the motivation to defeat interlocks. The next slide, unfortunately, will be a little bit text heavy, but it's trying to take some text from ISO 14119 and break down what the key recommendations were for those people designing machines and designing safety systems to give a prevention to prevent the motivation to defeat. The standard outlines really three key areas that you can do that. One of them is preventing accessibility to the devices, so mounting devices up on the top of machines, on the top of guarding where people can't reach, mounting them hidden or behind objects or inside the guarding itself to offer them shielded. We'll actually look at a photo of how you could achieve some shielded interlocks. The second bit is where you probably see most news or most people talking about it in the product literature and similar, is all around actuator coding, where people say, well, instead of that actuator just being the same key, like the key for your house, it always opens the same door every time. How about making the setter or the senior maintenance person can't come along to the interlock, install their key and run it with the guards open? They then define coding in 3 levels of code, and they say that there's low, medium, and high. Low coding is between maybe 1 and 9 variants. Medium is between 10 and 1,000 variants, and a high level of coding, which a lot of people aim for to reduce the risk of anyone putting in a spare actuator of the same code by having greater than 1,000 codes. The last thing to look at is actually where some of you with keen eyes will spot that there's an error in the artist's image on the right. Is that the other thing that people like to talk about to prevent the motivation to defeat is by using non-detachable fixings or security fixings to fix safety switches in place on machines. As you can see in that picture, they've used a flathead screwdriver, and that wouldn't really be acceptable because anyone could come along with any screwdriver, unbolt that safety interlock and open the guard while the machine's still running. Hopefully that makes sense, and that's the standards bit out of the way, and we'll start looking at some pictures. So one of the things that we talked about was that in that second point, which was around actually shielding safety devices to prevent them being defeated. This is a nice little picture from actually one of our customers of our trap key range. This is a screenshot of a YouTube video they've put out, where as you can see, the whole interlock assembly itself is mounted behind their guard. Without speaking to them directly when they designed that machine, I don't know whether they did that for aesthetic reasons or whether they did it for functional, but the functional benefit of that is that someone can't come along and defeat that interlock easily because it's shielded by the metal of the guarding itself. We then want to start talking about coding, and the first thing I want to touch on coding is just define some things about how you can actually achieve that more than 1,000 codes of the actuator some different ways. Those familiar with the Fortress range, or even some locks called the Ellis lock for anyone that's interacted with valve interlocking, you will recognize this type of actuator shape that's available within the Fortress AmGuard Pro range, where you can have up to 1,000 different codes within that actuator if you so choose, by putting these small hammer drive rivets all around the head. So it means that each one of these is coded like a barrel key, very much like a trap key system, albeit in a slightly different shape than maybe what you're familiar with. I have mentioned trap key a couple of times, and I have mentioned coding. It is worthwhile mentioning that it is worthwhile not to consider the coding of a key as being the same thing as the coding of an actuator. The actuator is the thing that you mount to the door to keep the guard closed. The key, if you're using a Fortress style system, tends to be the thing that you use to either access the guard by taking it from the power source and opening the guard. You can see on the right there a picture from one of our older brochures, which is actually just a photocopy of the page to try and offer something a little bit different. There's a picture here for anyone that might remember the old Fortress product. The other place that we see coded keys as well is where people might be releasing that key from the guard lock and the operator carries it inside the area to stop closing the door behind you. That's very much a way to prevent the door closing behind you and to prevent unexpected restarts. It's not a way of preventing defeating the system by using substitute actuators. That's mechanical coding, hopefully covered. The other thing to talk about with coding is methods of achieving that coding electrically, which then brings us back to the RFID point. So RFID tends to be something we hear a lot about in the industry and a lot about in the marketplace because it's used in a lot of technology. It's used in a lot of places to take a very simple piece of metal and make it into a high-coded device without making any mechanical changes. What Fortress has decided to do with that is actually use RFID to gain functional advantages by creating a really, really simple interlock design. So the interlock design itself can have this lollipop style actuator that is very, very simple in shape, and then this open receptacle receiving head on the guard to lock it closed. It can be so open and it can be so simple because you can put your finger inside of that, but because your finger doesn't have an RFID code, you might be mechanically defeating the device, but you'll never electrically defeat it without the uniquely paired actuator on the left inserting into the head that's on the right. The other functional advantages partly come from the material selected as well, is that the material selected there is stainless steel, and with that open head design, it means that dust, dirt, and corrosion aren't going to build up inside that head, and you're not going to have any issues related to that. Now, I do apologise, the next few slides are a bit product heavy, so we will look through them just to give you an overview of the product. But the other thing that we can gain an advantage of by looking at using an RFID coding method is not only that prevention of defeat, but is a real nice functional advantage when it comes to misalignment capabilities. So because we can make this actuator so simple, and because we can utilise this ball shape, we can make it self-centering. So you can use it down to guards with a radius of around 150 millimeters. You can also use it with guards of misalignment plus or minus 7 millimeters in up and down, left and right, and then plus or minus 6 millimeters in front to back. Sorry, I should say plus 6 millimeters in front to back. It won't actually go negative distance inside the interlock. This is actually some market leading characteristics. You will see some other competitive products with around 2 millimeters or 3 millimeters of misalignment capability. So if anyone does have an issue with misaligned guards that sag or drop over time, you can use this type of technology to allow you to have some ease of operation. Then this slide is then probably just wrapping up what's been alluded to on the last two slides. This is a product that we call at Fortress Atom because it's nice and small. And then it's the product that's using RFID coding within the range to gain those functional advantages on the right of the high degree of misalignment. But it's like every other Fortress product. It's all metal construction. It's very robust. It has an 8,000 Newton retention force. So you can hang around 800 kilos off it before it breaks. It's then got that open head, which benefits from not having dirt or dust buildup. It also makes it directly padlockable. So you can put a padlock hasp straight through the head to lock it off while you're keeping a guard open. Just now on the back of the unit there, it's IP65 and IP67 rated. And then at the bottom of the unit, there is some local LED status identification where you can see whether it's unlocked, locked, or maybe if the wrong actuator is inserted, it'll flash orange to say, I've got a problem here, the wrong actuator has been presented to me. Hopefully that makes sense. These slides are available afterwards, and if you do have any questions, do ask us. I am going to try and answer a few questions you may be asking over the next couple of slides of what do we mean by compact? Well, by compact, we mean that it actually fits inside a 34 by 40 millimeters by 153 millimeter envelope. So we talked very much at the start around how you can prevent defeat by mounting interlocks in discrete locations, hidden away. Well, because the atom unit is so small, you can do similar things as well. You can mount it at the top of the guards in the corner. You can mount it in both directions because it's got holes in the front and in the sides to easily mount it to something like aluminium profile shown on the left, but it will go to plate guards and similar, however you choose to mount it. The other question you might be asking is, we call this webinar compact and robust. What do we mean by robust? So if anyone has actually followed our Texan regional sales manager, you will have seen that he drove his GMC Terrain. Sorry, that's a GMC Terrain. He drove that. It weighs around, I think, 4,000 pounds. Rather weirdly, he calls it a car, but I would almost call it a truck. But he drives it over the interlock in the video that he's put up on his LinkedIn to try and demonstrate how robust the device is. The fun story there is actually it took him 3 or 4 takes, I think, to get that video correct. So he ended up driving over it multiple times. But just to try and spoil the video, there's no real effect to the interlock. He's able to pick it up off the ground and it functionally still works. The other question that you might have asked, just to preface as well, is what about connections? The device itself has multiple connection options. And I will say that before I joined Fortress, I didn't know much about cabling. And now after working for Fortress, I probably know far too much about cabling than ever I really wanted to. And I'm sure there's some people on the call that know far too much about cabling that the other thought they would. But Fortress's Atom unit is available in a couple of different connector types. You can have 8-pin variants and 5-pin variants. The 8-pin variants allow you to have monitors. The 5-pin variants allow you to just have simple wiring with no monitors. And then you have a daisy chainable variant where you actually have one male and one female connector to allow you to connect through the device to the next one in series. There's a picture of that on the next slide that we can talk through. The only other thing I wanted to highlight on this slide was that there's the ability to include an auxiliary override at the bottom of the unit. So if all the power was turned off to the machine, you could insert a security tool there and unlock the interlock by using that security tool to mechanically override the locking mechanism inside. I promised there would be a picture showing that daisy chain arrangement. This picture actually shows the Atom unit being connected up to 8 times in a row. The reason it's able to do that is that each device supports OSSD inputs and outputs. If you don't know what that is, it's possibly something worth looking up and educating yourself. I don't want to go into too much detail here, but basically it uses some pulses with the inputs and outputs to allow you to make sure that not one of these devices has been short-circuited and that chain is actually shorted and not running safely. The reason the Atom unit can go up to 8 is that because we just monitoring voltage drop along that cable run, as each Atom unit itself will be drawing some voltage to unlock and power itself. If you were to go for maybe the 9th unit, you'd be starting to have impact on voltage drop. The other thing that we'll talk around as well is that the cable lengths in between might offer some voltage resistance as well. Those are thinking that where we showed that picture of it being mounted to the aluminium profile and maybe that wouldn't suit in their application, we do have some ability to offer some accessories and brackets to make it a little bit easier to mount. The unit itself is very, very easy to mount because you can mount it through the front or through the side, but for the actuator, we can provide right angle brackets that allow it to be mounted to maybe a sliding guard. We could then offer handles and similar. We've also had a few customers in Europe select that thing that's in the bottom left, which is called a slide bar, where maybe they close a guard closed and then they use a mechanical secondary movement to insert the actuator into the unit. Like I said, that was a bit product heavy and I didn't want to go through those in too much detail. I wanted to go through them quickly and I wanted to leave you with enough information to say, well, where can we go from here? Well, if anyone was particularly interested in going through the range, you can have a look at this part number breakdown in the presentation that we make available, where you can have a look at what the actual options available. There's only around 16 different Atom units available between the different connector types: power to unlock, power to lock, with the auxiliary release and without the auxiliary release, to form a simple part number like you see in the top right of ATM 100A1-A. But if you're going through the part numbers and filling out an Excel sheet's not for you, there is an easier way to do it, and that can be by going to www.fortressinterlocks.com and having a look at the Atom selector under the Configure a Product menu. On there, you can just go through a tick box exercise, and then at the bottom, you can get a link to the CAD files and operating instructions for the unit if interested. Alongside that Atom selector, you'll see at the top of this slide where you see voltage drop tool and Atom accessories. There are some extra tools available on the Atom selector to help you plan and manage a machine. You can input how many units you plan to have and what your cable lengths are, and then we'll basically be able to advise, if you're running 24 volts to the first unit, what the voltage drop is likely to be when you get to the last unit. As you can see in this arrangement for the 4 interlocks, that maybe, I can't remember what cable input was put across, but you can see it's come up as an orange warning to say you might want to consider that last unit. It's not reached its limit yet, but if you were to have a voltage drop from the power supply, you might start seeing some impact to that last unit when it was trying to lock and unlock itself. Hopefully that makes sense and that gives you something to think about. As a follow-up to this presentation, we will be sending on the operating instructions and a link to the YouTube video, which is basically an explanation of what we've talked about today and what I've talked about today, but something you can digest maybe your own time or send on to someone that's maybe would be interested that wasn't able to attend today. Hopefully that's wrapped up the bit on product in Atom, and now we're just trying to move on to that last bit when we're talking about hygienic applications and maybe some interesting stuff no one's ever seen, and maybe this is solving a problem for something someone has. So this is where we can introduce the fact that the Fortress Atom can have a big brother, which is available in full stainless steel. When I say available, it's really available for pre-launched installations at the moment, because we're going through a few tweaks and approvals to make it a little bit more hygienic and make it basically land on the doorstep with that TUV certificate, rating it up to category 4 performance level E. To go through again the features here, it looks very, very much similar to that Atom unit, but in the full stainless steel package. It has a few key differences where you can see at the front, it's got that much bit more open around the mechanism there. That's to allow it to have that open design for washdown. So if any material got stuck inside that mechanism or inside that head, you'd be able to easily wash it out straight from the front through to the back. We'll talk a little bit more on hygienic standards on the next slide to advise someone that's possibly not familiar with how hygienic standards work. It's still got that high-coded RFID links and more than 1,000 different codes between the actuator and the interlock. So you can't take a spare actuator and defeat the interlock. It's still then got that high degree of misalignment, and still here you'll see that actuator is open to allow it can be washed through if any material was to be stuck around the back of that actuator unit. At the bottom, we've got full stainless steel connectors, and there's some suppliers out there that we deal with that make FDA approved food safe cabling, so it can be partnered up with a food safe cable as well. You'll then, probably the last thing we'll touch on is that if you look around the unit, you see these blue, or these bits of blue material and these blue seals used everywhere. Those are from a food safe gasket sealing material. I can't for the life of me remember what that material is called, but I know that our design engineers did some investigating work to select the correct material there. So you'll see that any points within the product where metal to metal tries to join, so where maybe those screws are made of stainless steel and the interlock is made of stainless steel, it can be fitted with that blue gasket to mean that there's no small gap that maybe food or microorganisms can grow in between the two bits of metal. There's this crushed seal that prevents anything going between those gaps. That's then similar for the back of the unit, is then that back plate is sealed on with a bit of blue gasket material as well. The last thing then to note is that it's supplied with those, or it can be supplied with those standoffs to allow it to be mounted on a machine, but with a slight gap between the wall of the machine and the interlock. So if any material was to go behind the interlock, it wouldn't get jammed up in a small gap. It would either fall straight through the gap, or it would facilitate easy cleaning in an open plant method. Hopefully that's gained some interest, and then we'll talk around, well, some of you might have looked at that and says, well, actually that isn't hygienic. It's not hygienic, I wouldn't eat my food off it. And then it's this point where we start to talk about actually what do we mean by sanitary standards that affect the food manufacturing industry. So it's worthwhile to review them. Is that if you were to go on a website like 3A, which is an American organization which focuses on the sanitary standards for food manufacturing equipment, they refer to something as open plant cleaning or clean in place devices. So we would categorize an interlock as an open plant cleaning device, which means it's mounted on the outside of the machine so that it's in the open air of the manufacturing facility and gets cleaned along with the rest of the outside of the machine. That contrasts against a clean out of place or a closed plant cleaning device, which would be more like maybe the inside of a valve that controls the flow of material in food manufacturing. That would be closed plant cleaning because it's inside and it's not exposed to the outer elements of that facility. So just to repeat that again, we would categorize an interlock as an open plant cleaning device. That means 3A can then offer some guidance as well and says that any device that's designed to be open plant cleaning and cleaned in place without detaching to the machine should be designed and fabricated so it can be cleanable. That comes back to the points of making sure it's all open to allow people to wash all the way through it. They then say those devices should be selected with materials that are compatible to the product, but also the aggressiveness of any cleaning chemicals used. So by going back to a stainless steel unit opposed to a plastic unit, you have the ability for it to resist any caustic washdown or any sort of type of acidic nature that might be in the food product being manufactured as well. We've already covered the point around the blue seals and similar regarding that any product should reduce the number of cracks and crevices where product residues may lurk. That means for us, we're using those blue seals to stop a metal to metal join, then the last couple of things to look at is that the product contact surfaces, so any surface which food material might get in contact with, should be nice and smooth to allow material to run off it and facilitate the removal of soils. Also, on the right-hand image, we've tried to do a cross-section of the device to show how it might work internally. And as you can see, each one of those faces is angled. So if any liquid material was to land on it, either during food manufacture or during washdown, it would run off those angled surfaces and run away and drip and drain onto the floor. So those surfaces are not only smooth to facilitate material running off, they're also angled to facilitate material running off. And then the last point is every surface that can be touched by food product should also be in contact with the cleaning solutions applied. So that comes back really to the facilitating cleaning and making it cleanable. Is that any surface that can come in contact with food needs to be available for that fire hose or jet wash that comes along at the end of a shift and cleans it all up. That's really the end of the presentation to give you an overview of what we talked about. We talked around RFID coding, we talked about what functional advantages you can get, and then we finished up with those functional advantages talking about really for hygienic applications, how it can be applied. The rest of the presentation is that all-important poll that we mentioned, but first we do want to say that this has been probably one of our biggest product-focused webinars, so we are interested in some feedback. Most of our other webinars focus on educational content for either standards or solutions that are available for the industry. So we did one on access control last week of implementing RFID access badges, very much focused on a solution. We're also doing ones on the B11 machinery standards for the Americans, and then we've also got some coming up, maybe some more specific machinery standards. If anyone is interested in keeping up with Fortress content, there is a pinned post on the Fortress Interlock's LinkedIn page. Probably at that point, Eve, if you're still there, it's available to ask some questions if we've had some.
I am still here, and we have had several questions. If anyone does want to ask any more questions, jump in the Q&A and we will try and get to them in the next few minutes. First question that we have had is, with the actuator in, what is the maximum distance before the RFID is triggered when you're pulling back on the door?
Oh, so the maximum difference, so actually, yes. So if we remember what both the types of units we looked at today, the actuator has that over travel allowance to allow a door to move with it. The RFID link is then sat below the mechanical link, which is that lollipop shape. The distance we spec for those is 6 millimeters of over travel. That actually is mechanically limited by the actuator above. So that actuator is not long enough to allow it to be any longer than 6 millimeters before the door would be either unlocked or the door would be, the door would come up against the locking mechanism, or if it was unlocked, it would be open. Once we've set that mechanical distance in the actuator, we then set the RFID link to be the same level as well. So that's where a bit of the technical expertise comes in to match up the strength of the RFID signals to match the mechanical link at the top.
Sweet. Another question we've had is Atom, and I guess you might as well mention CTEC while we're at it as well, IP65 or IP67?
So very interesting. So I did mention that on the slide, IP65 and IP67, so it possibly might be worth clarifying that and then talking about CTEC, because I probably didn't mention it. The Atom unit itself is rated to both standards. If that's not familiar to anyone, it's because IP65 is focused around resisting dust, and IP67 is around resisting water ingress when a unit is placed at 1 meter depth in a water tank for, I think, an hour. But there is a test specific of saying it needs to be buried at 1 meter depth on water and not allow any water to enter inside the unit. The CTEC unit is then additionally rated to IP69, which means it can resist a high temperature washdown with a high pressure solution. So for that test, I think they used 80-degree water and then they jet it at a certain flow rate onto the surface of the device to make sure it doesn't leak.
Okay, Perfect. Kind of moving on from that, another one we've had similarly is, will there be mounting hardware or brackets for the IP69 version?
So, okay, so that's tying together two things that people looked at in the presentation. We do have the mounting brackets and hardware available to mount the actuator on that L-shaped plate for the Atom unit. For the C-Tech unit, which is that hygienic variation, we plan to make available those machine standoffs. If I just go back to them, we plan to make those little machine standoffs available to facilitate anyone mounting up to a machine to make their lives a little bit easier. So no one needs to jump on and machine their own components. We'll be able to supply them alongside some of the gasket material to facilitate a nice, easy mount to the side of a machine. Hopefully that clarifies that.
Yeah, I think so. Two more questions that we've got, if we've just got time. Hopefully they're not too long answers. First one is, are there any diagnostics available with the Atom, such as the distance between the RFID reader and tag, that would tell you if the door is beginning to sag?
So there isn't maybe a diagnostic output which is like a encoder or something which tells you the distance, but there is a diagnostic output that can be used for that type of application. In the 8-pin variant, there's the ability to have that monitor contact, and that monitor contact relates to the RFID link. So you can see that the door is maybe closed and locked, but maybe you'll see that the door has started to sag, or maybe they've used the wrong actuator. And then that allows you to interpret from that monitor link not being there that something's happened with the Interlock device.
Awesome. And then last one I've just noticed in the chat is there an emergency or an escape release available?
So emergency and escape are two different definitions for me. Apologies for going to a longer answer there, but emergency would be like a pull cable, which maybe you can activate from the outside so you can unlock the guard. That is something that we've talked about and relatively easy to adapt to an Atom unit. So if there is an application for emergency release, we can look to supply something. Where we looked at that override key at the bottom of the unit, there's actually a threaded hole at the bottom of that in the Atom unit to facilitate a cable or similar being added to it to allow you to have a pull cable that unlocks the device. When it comes to an escape release, again, that's something that we've heard requested previously, so we are interested in some feedback. It's currently not available as an escape release, which would typically be like a red panic button inside the area that if you're locked behind the guard, when you press it, the guard would open. That's not currently available, but if someone does have an application, get in contact and we'll be able to have some conversations about it.
And just to add, the third release type, the auxiliary release, is available as the override.
Cool. We've ticked off loads of standards today. What a fun presentation this has been. Yeah.
What kind of presentation?